The fundamental objective of structural design is ensuring a component will not fail when it is subjected to the loads that it was designed to withstand. To enable you to design structural parts, we need to introduce you to the concept of stress limits. As you gain more experience, you will also find that strain limits can also be very important. But for now, we will only discuss stress limits. In the Intro to Stress and Strain video, we showed you an example of some typical material properties. The stress limits for a material are typically listed under strength properties. In structural design, the three most important strengths to consider are yield strength, ultimate strength, and fatigue strength. First, we will focus on explaining yield and ultimate strength. Let's start with the plot of stress and strain, and the spring from a ballpoint pen. If we pull on the spring, and then release it, we will move up and down the same straight line. After we completely release the load, the stress and strain both return to zero, and the spring returns to its original length. Let's see what happens if, instead of unloading the spring, we continue to pull on it. If we pull on the spring too much, it does not return to its original shape. This is due to the fact that at a certain level of stress, the relationship between stress and strain stops being linear. We call the point where this happens the yield point. For the spring, we continue to load it well beyond the yield point. When we release the load, we follow a new path. Once we remove all of the load, the stress returns to zero. But the strain does not. Physically, we see this as the permanent change in the length of the spring. We call this a permanent deformation. The ASTM organization has defined standards for measuring the mechanical properties of engineering materials. We have listed two of the standards here. We will use a simulation of the test, defined in Standard E8, to help you make a physical connection to the published strength numbers. The test coupon starts out gray. As it experiences plastic deformation, it becomes blue. The color changes as the amount of plastic deformation increases, with complete failure occurring when it becomes red. The elastic modulus is the slope of this line. For most metals, the yield strength is defined to be the stress level at 0.2% strain offset. The ultimate strength is defined as the stress level where the specimen starts necking down. Nearly everything that we design must withstand more than one application of load. However, accurately calculating fatigue is an extremely complex subject, and well beyond the scope of this introductory video. For now, we just present you with some of the important factors that affect fatigue, and the warning that we cannot easily design to prevent fatigue using the fatigue strength listed in a reference book. We are now ready to use stress limits to design a structural part. To do that without explaining everything that you need to know about fatigue or dynamics, we will introduce the concept of a factor of safety. Depending on the type of loading, the factor of safety is defined as the yield strength divided by the allowable stress. Or, it is defined as the ultimate strength divided by the allowable stress. This is the case for repeated loading. We have borrowed the recommended factor of safeties from Dr. Michael's Strength of Materials course notes. This is best demonstrated using an example. We will design a part using 4130 steel that is subjected to a repeated load. Using the definition of the factor of safety, we can solve for the allowable stress. So, the allowable stress is 77.6 megapascals. We are now ready to show you how you can use the allowable stress limit with 3DEXPERIENCE. To do that, we will introduce a trailer hitch application. Right now we will concentrate on designing the ball. To facilitate our discussion, we have created a section view. For this simple case, we will assume that the trailer applies the following two loads on the ball. A vertical load, due to the weight of the trailer, and a horizontal load, due to us pulling on the trailer. We can apply these loads to our model in 3DEXPERIENCE. After we run the simulation in 3DEXPERIENCE, we compare the Van Mises stress calculated to the allowable stress limit. Since the von Mises stress is only 50.2 megapascals, the design of the ball is acceptable.